All right, for question number one, it says, please explain what a misconception is as it relates to the science instruction. Be specific and give examples of at least two common science misconceptions. So to me, a misconception is when a person has an idea about something that's going to happen, but then they realize that it's a mistake of what they thought was going to happen. So people can learn best when they learn from their mistake. People, when I did the misconception interview, with the students had a misconception about how the ball would go around the track. They thought it would keep spinning or go straight rather than go straight when it exits the track. Then another misconception could be determining whether something will float or sink. And so I think that the misconception interviews was a good way to put to life the real misconceptions of how and what students think. And then for number two, it says, explain how leverage student misconceptions of science phenomena in your future classroom to help teach those students. So for me, after having the students explore their misconceptions on their own and trying to get them to realize that they have a misconception, I would then explain to them the reasoning as to why they had that misconception, and along with doing the experiment and their exploration with them to prove that it was a misconception, and just make sure that they realize that a misconception is a misconception and they're always happening. And then let's see, this could also be used as a learning experience, as the students could then realize that there are a lot of misconceptions that could happen. Even just in the real world, they can realize that there's misconceptions that are always happening, and that they can always just be aware of not like a misconception so they can make sure they're accurate. So number three, it says progression of standards. Please explain what the term progression of standards means in regards to NGSS. Be specific. Give details at least one linear progression of DCI from K to middle school. So the term progression of standards in regards to NGSS is the ability to build upon a DCI over many years. And the example that I thought of is for, say, PS2 from K to middle school is all over motion and stability, which is the forces and interactions, but it's increasing throughout each grade. So like in kindergarten, the DCI says pushes and pulls can have different strengths and directions, along with stating different types of interactions at a kindergarten level. And so each grade level would get a little bit more in depth. And so if you skip to third grade, the DCI continues to talk about forces acting upon one another, along with the interactions that exert on one another. So that's just from kindergarten to third grade, that's just a big difference of how the teachers would incorporate and teach those students the same standard over the same topic. So then if you go to fifth grade, the DCI standard talks about interactions involving gravitational forces on Earth. This goes along with middle school interactions, where the students are understanding ideas relating to why some objects keep moving while some objects fall to the ground. Throughout the years, the students just will get more in depth and have more intense standards that they follow for the DCI. Now, for number four, it says, please explain what your role would be as a fifth grade teacher, focused on teaching content related to the NGSS performance standard expectation for 5PS 1-3, and include information about the standards before and after fifth grade. So for me, I thought that when I was reviewing these standards, it was basically just showing that these students will be able to make observations and measurements to identify materials and their properties. So before the standard, before they come in my classroom, they should already know, the students should be able to make observations to construct evidence based on account on how an object of a small set of pieces can be disassembled and made into a new object. And then my role as a fifth grade teacher would be to teach the students how to make observations and measurements accurately to identify materials on their properties. I could have the students identify materials such as powders, metals, minerals, liquids, and also have them organize it by like their color, hardness, and different things like that. Then after the students have learned this standard in 5th grade, they can continue their knowledge in the standard and learn how to formulate an answer to the questions. And that's at like the middle school standard for this, for PS 1-3. And then number 5 is the 5E learning cycle. And they just want us to explain the 5 stages in detail. So the desired outcome for engagement stage is to catch the students' interest and attention while not giving any hints or tips as to what we will be doing the rest of the lesson. That's for engagement. So then exploration is the outcome for students to explore and try out the activity just by using their background knowledge and not being able to, and as a teacher, not guiding them, just letting them explore on their own. The explanation stage is there to have discussions with the students and explain the thought process behind what they were exploring in the exploration stage. So the students are then able to take the new ideas that they learned in the explanation stage and put them to use to try the exploration stage again using those ideas. So the last desired outcome is the evaluation, which will the teacher was trying to assess and measure if the students understand and meet the objective. So the elaboration is when the students will go back and use what they learned from the explanation and retry that engage stage, the exploration stage, redo that with the explanation that they just received from me. So the different activities that go along with each 5E. So if we were doing a lesson over habitats and packs of animals, there are different things that we would do for each E. For engagement, the students could listen to a short clip of animals making sounds and try to guess in their head what animal is making that sound. And now for exploration, the students will be told to gather as much food as possible by themselves, followed by grouping students as packs of animals to see how much food the pack can gather. Discussions would then take place for the explanation stage, and then questions would be asked to get the students thinking why things happened and why they were the way they were, which will get students pondering different questions and thoughts to themselves. To become more aware of the packs and animals, they will fill out a paper during elaboration stage to see the strategies and benefits for the animals and packs, followed by playing a game using the strategies they came up with, the same game that they did for the Explore. Lastly, the evaluation stage will include an exit ticket, asking the students about the lesson to ensure that they understand what is happening. For number 6, the EIE version. EIE is the beginning of activities that tap into the natural curiosity and creativity of all children. All students are born engineers as they are fascinated with designing their own creations, taking things apart, and figuring out how things work. I think this all happens as teachers are working together with engineers to develop a research-based, standard-driven, classroom-tested curriculum that integrates engineering and technology in the elementary classrooms. So that's all I have on EIE, which is number 6. Number 7 for my feedback. I felt that the group teach modeling the 5E lesson plan was the most beneficial to me as a future teacher, because it was a good way to cooperate with my peers and create a meaningful science lesson that I could teach to my peers. After presenting to our classmates and hearing their evaluations and recommendations as to what they saw and what they thought we could fix, was a neat experience, because this was a way to better me as a teacher by learning from my peers. The assignment that I felt is the least helpful, I would say, is the classroom safety posters. I thought that it wasn't as helpful because the rules weren't stated. They were stated more basic science rules that are more common. I didn't think I gained as much knowledge from this assignment as the other assignments. But yeah, that's all I have. Thanks for teaching us.